Okay, so after finding out how to work out binomial probabilities, there are a couple of the other properties of the binomial distribution you need to know about. You need to know about its mean and its variance. So actually we've got a few new symbols going on. We call the mean of a probability distribution by the letter mu, Greek letter mu, and not by x bar, because x bar is the mean of some sample data. When we talk about the mean of a probability distribution, we mean the underlying mean that you would get if you could do the experiment an infinite number of times and average it out over the long term, rather than having to rely on just a sample of data, which is what x bar is for. Okay, but yet another symbol for the same thing, another thing we say is that the expectation or the expected value of the distribution is another name for the mean. Okay, and the variance, again, for sample data, you'd call the standard deviation Sx, and you'd call the variance Sx squared. Well, for a probability distribution, we use the symbol S, Greek letter sigma, sorry, instead of S, to mean the standard deviation. So sigma squared is the variance. So and we can call that var x. So expectation of x and mu both mean the mean of the distribution. Var x and sigma squared both mean the variance of the distribution. Okay, and for interesting reasons, which I'm not going to explain in this video, for a binomial distribution, we can work out the mean and variance with these formulas. The mean actually is a fairly easy one. If we think of an example, for example, suppose I was rolling a dice 12 times, so it would be a binomial, and there are 12 rolls, so it would be 12 trials, and I'm counting the number of sixes I get. Well, the probability of getting a 6 each time is 1/6. So I'm doing something 12 times, and on each time I do it, there's a probability of 1/6 that it will happen. So on average, you could probably tell me that out of the 12 rolls of the dice, 1/6 of them on average would be sixes, so I'd have to do 12 times 1/6 and get 2 to get the mean number. And this formula here is telling me exactly that. In order to find the expected number of successes, I'd do the n value times the p value. Okay, and the variance formula starts out the same way, but in fact I just do n times p times 1 minus p to get the variance. Okay, which may not be as obvious, but it is true. Now, these formulas are in your formula book, but it's not really enough to know that things are in your formula book. You need to know whereabouts they are in your formula book. So that's why you have a copy of the formula book, so you can practice looking things up. So up till now, you've been using quite a lot from this page. Here are your formulas to do with correlation, and we've got regression, we've got the b value, and we've got the formula you might have to use for r. They're all on page 13 of your formula book, but you need to go back to page 11 for what we're doing here. So that's the bottom of page 11. We actually need to be in the table on the top. So very first one in the table for a binomial distribution. Okay, here's the formula for working out individual probabilities, which we briefly looked at. This is the n choose r part that in the booklet was printed as NCR, but this is how it's printed here. If you've got the calculator that you should have, you shouldn't need to use this formula ever. Okay, but the formulas for mean and variance, here they are, NP and NP 1 minus P. So it's page 11 of your formula book. So make sure you know where to find them. Now, once you know where to find them, questions like this, find the expectation of x and the standard deviation of x for this. It's just about knowing what the formulas are, where to find them, and just dealing with words like expectation and standard deviation. So, firstly, let's decide what n and p are. So n always comes first, so n is 3 and p is the quarter. Okay, and I want the expectation of x. So the e of x formula, remember in the formula book, it doesn't refer to it as e of x or expectation, it calls it the mean. So we need to decode expectation of x or e of x into the mean, which we could also call mu, and use the formula np, which is the easy bit. It's 3 times a quarter, which is 3/4. And then for the other one, I want the standard deviation. Okay, well, to get the standard deviation, I'm going to use the other formula, the formula for the variance. I'm going to use the correct symbol for that, the variance of x, okay, which from the formula book equals np 1 minus p, so that's going to be 3 times a quarter, and 1 minus p is going to be 1 minus p, which is a quarter, so that's going to be times 3/4, so it's going to be 9/16. Okay, so that's the variance of x, but remember the variance is sigma squared. It asks for the standard deviation, which is just sigma. So to find sigma, I have to do the square root of 9/16, which my calculator tells me is also 3/4. Okay, so that's a bit of a coincidence that the mean, the expectation, and the standard deviation are the same number. Doesn't normally happen, just happened to this time by coincidence.